Hello Finxters and welcome to this new Pandas tutorial. Today we are looking at the two Pandas functions loc and iloc. We will see what these functions are, what they do and how they differ from each other. First we are having a look at a simple example where we first import the Pandas library, then we have the example data, and then we create a Pandas data frame with the example data and the indexes dog, cat and fish. And the output looks like this. It's a simple data frame, and for the dog, cat and fish we have each speed, height and length, so these are the values that we are working with. We start with the log function, and essentially the log function accesses a group of rows and or columns based on their respective labels. So if we try that, we type df, which is the data frame dot log, and inside the square brackets we state which row we want to access. Let's start with the fish, and this is what it looks like. For the fish row we get each column's value. So it has a speed of 8, a height of 0.1 and a length of 0.2. We also get the name of the row we are accessing and the data type, which is float 64 in this case. It's also possible to have this function output a data frame, and this looks like this. We use double square brackets, so this basically means that we are putting in a list into the log function. Let's use the fish again, and the output shows a data frame with only the fish row showing. We can of course also put in multiple rows. This looks like this. Use df.log, let's say dog and fish, and the output again is a data frame because we are using double square brackets, and we only get the dog and the fish row as an output. So by now we've seen how we can access rows. It's of course also possible to access columns as well, and this is what it looks like. We say df.log, then we put in the column, and after the comma the column that we want to have. Let's take the height, and so then we get for the height column every row value basically. So a dog has a height of 1.0, a cat has a height of 0.3, and a fish has a height of 0.1. Again, we also get the data type and the name of the column. And what this code does is, before the comma, we state which rows we want to show. And if we only put in the column, we say that we want to have all the rows. And after the comma, we say which columns we want to have shown, which is in this case the height column. It's also possible to access a specific cell, not just a group of rows or columns, just one specific cell, and this is how we can do it with the log function. Again, we say df.log, and then we say first which row we want to access. Let's pick the fish, and then the column we want to access, let's say speed, and as we can see, the output is an 8, and if we have a look at the data frame, we see that the fish speed is indeed 8. So all in all, the log function is a very efficient way to access, whole rows, whole columns, or even very specific values. It's also possible to use conditionals for our accessing using the log function. We type df.log, and inside the log function we put a conditional, which could be, for example, that from the speed column, we want to have every row where the speed is bigger than 6. And the output shows a new data frame, but it shows only the values that have a speed that's bigger than 6. So this is a very nice way to filter your data based on the values within the data frame. So inside the log function, we put in the condition, like what to show. And the condition here is that show only the rows that have a speed that's bigger than 6. So now we have seen how to get certain values. Using the log function, it's also possible to set new values. This works essentially the same as getting the values, just that we equal these values that we got to a new value. And I will show you how that works. We say df.log. Let's say we want every value in the doc row to be like a new number, for example 9. Then we say df.log and we access the doc row like this, df.log from doc, as we've seen before. Now we say this row should be equal to 9. And of course we call this new data frame, and the output shows a new data frame, as you can see. And what has changed is that the doc's rows values are indeed 9 for every column. But as you can see, we said that we set the doc row to an integer value 9, but Pandas automatically transfers the 9 to the column's respective values. So in the speed column, since it has a data type of int64, we get a new data type which is also an integer, but with the height and length column, the 9 is transferred to a float number, 9.0, because the height and length respective data types are float. So Pandas transfers them automatically, which is a very nice thing. We can of course also create like new values for a column, and we do it like this, df.log. We want to access again all the rows. We state that by the column, and then we say, for example, the speed column, we want all the values to be 11. Again, we have to call the new data frame, and as you can see, the speed values for every row are indeed 11 now. We can also use the conditionals we've seen before to set new values. We do this like this, df.log. Inside the log function, we say, for example, that we want every value in the height column that's smaller than 1. And we want to access the height column here. And we set these values to 4. So every value in the height column that's smaller than 1 gets set to 4. And if we call this new data frame, we can see that if we compare that to the data frame above, that indeed all the values in the height column that have that are smaller than 1 are now equal to 4, or 4.0, because again Pandas changes or adapts the new values to the respective data type. And next we will see how the Iloc function works. And the Iloc function basically means that we access groups of rows or columns by their integer location. And I will show you how this works now. Again, we type df and then .iloc. Again, we use square brackets, and let's say we want to have the first row. And as you can see, we get the first row because we input a 0, which accesses the first row. And as you can see, we get the values for the first row. The first row is dog, so we get the dog's speed, height, and length, and also the data type. And like before with the log function, it's also possible to show that as a data frame with using double square brackets. And this is what we can see here. And as you might have guessed, there's also a way to access columns instead of rows. We do that basically the same as with the log function. Again, we say df.iloc. We put in a column. That means we want to access all the rows. And let's say we want to have the third row, the third column. And as you can see, we get the length column with the dogs, cats, and fishes respective value for the length column. Basically, these getting methods are the same as with the log function, instead that we just use integer locations instead of the labels of the indexes. Like we couldn't write df.iloc of dog because the iloc functions only works with integer values. And it's also possible to use the iloc function for setting new values. We can do this like that, df.iloc. For example, the first row should have values of 3. And again, we have to call this new data frame. And as you can see, the first row indeed changes to 3 and adapts the data types as before. We can also, for example, set new values for specific cells. We do this like this, df iloc, and let's say we want to change the second row and the third column, and we want to set that to, let's say, 7. Then we call the new data frame. And as you can see, if you compare these two data frames, you can see that the value of the second row and third column, which is the cat's length, has changed from 0.4 to 7 or 7.0. And now I will show you how these two functions differ from each other. To see how they differ from each other, we will have a look at another data example. We have a list with several animal names: dog, rabbit, whale, shark, bird, and cat. Then we create a Pandas series with the data and the indexes 4, 5, 6, 1, 2, 3. And it looks like this. You have the animal names and the indexes 4, 5, 6, and 1, 2, 3. And as you can see, the indexes are not in the correct order. This is because it's important to see how the two functions differ from each other. And I will show you how. Let's say we want from the series, we use the log function and put in 1. And the value we get is shark because the log function works label based. So it looks for which index is named 1. And this is the index 1 which has the value shark. Whereas if we use series.iloc of 1, the output we get is rabbits because the iloc function looks for the integer location of 1, which is the second row. So it doesn't look for a label which is called 1, but as I said, for the location. So this is the second row. And as we can see in the series, this is the rabbit. So this is the most significant difference between these two functions, and in a lot of use cases these are very similar to use. It depends on how you call your indexes and so on, but all in all these are two very powerful functions to use for your data analysis processes when you're working with Pandas. recommend you read the official documentations of these two functions. And yeah, that's it with the tutorial. I hope you liked it, I hope you enjoyed it and you learned something. If you're looking for more nice tutorials for Pandas stuff or Python stuff, check out the Finxter blog page, and I'm happy to see you in the next video. Bye bye.